All right, see if we can find John now.
Good deal. Awesome. Thank you. Thanks everyone who hopped in and hopped off as well. Appreciate it.
We are going to just take one more minute to wait for one of our other panelists slash hosts to join. Yeah, I don't see John yet, do you?
No. To be fair, the link did take a moment to get over through
No problem. And we have about 90 people registered for today. So some things do come up sometimes, but we'll give it another minute as people get logged on.
Awesome. Thank you.
Can kind of see that attendee count going up.
Awesome.
Glad I did take my blood pressure pill today.
Oh, John, too young to be. That's good.
Oh, they just send a quick reminder out. So let's get up to at least half our registered attendees. And then we will get started.
Mm-hmm.
All right, just sent a quick reminder out to everybody too.
Thank you. And yeah, it looks like you said we got about 50%, a little less on right now. So thanks to those who are already on.
Yeah. Hey, Stacy. You're on mute, Stacy.
Are we still in like we haven't broadcast it yet, right?
Yes, we are actually.
Oh, okay.
There he is.
We had some tech challenges, so we ended up in broadcast.
Going away. Okay.
Thanks, Stacy. Good to see you. John, you on? You good?
Hey, John, how are you?
There we go. He's connecting.
Yep.
John, can you hear us? We see you.
Can you hear me?
Yep. Hear you now.
You're muted. All right.
It looked like you might have muted yourself a second ago. There we go.
There we go.
Awesome. All right. Well, thanks everyone for coming. It looks like we got 50 people here. Appreciate that. Jan, do you want to do an intro?
So welcome everybody to our September NACE Connect with Gallagher Asphalt Hot and Recycling Division. Thanks for bearing with us on those technical difficulties as we got started. Just a couple housekeeping notes. We do have everybody's phones on mute, cut down on any background noise. You can also turn your video off if you'd like to. So actually, I think I have everybody off, so it didn't drag too much in with. We will also, just everybody knows, after the webinar, we will email out all registered attendees their PDF certificates. Those will come out within the next 10 days, so keep an eye on your email. The webinar today is scheduled for an hour, and it'll also include some question and answer period. If you have a question, please feel free to type it in the comment box as we run through it. For those that don't know, I'm Jen Bochelle. I handle the marketing and membership services for NACE, including working with our corporate members like Gallagher Asphalt to bring our members the opportunity for professional development hours throughout the year with our monthly Connect webinars. We haven't had one in a while, so we're excited to kick this month off with Gallagher's Hot and Waste Recycling Division. I said we had over 90 people register, so hopefully we'll get more popping in throughout. And now I'm just going to introduce Mr. Joe Dillon, who is the technical sales manager for Illinois, Wisconsin, and Minnesota for Gallagher's asphalt hot in place recycling division. Joe received his degree in mechanical engineering from Iowa State and is currently enrolled at the University of Illinois Urban Champaign campus, pursuing his Master of Business Administration. He's been with Gallagher the last 3 seasons, and prior to his career with Gallagher, he was an electrical engineer and an electrical superintendent. He is a one-stop shop in each of the states that he manages, from the process from pre-construction through completion and beyond. So prior to Joe's work with Hot in Place, he was the project superintendent for 2 seasons at Gallagher Asphalt, the parent company. So outside of work, Joe was a golfer. Daydreams of smooth roads. I could tell you we could use a couple of those in my neighborhood. And it likes cheering for Bears, so which he called abysmal, but you shouldn't be negative about your team.
Not very good.
So Joe has a couple of folks joining him today. Did you want to introduce the panel, Joe, or do you want me to go through it real quick?
You know what? I was gonna, since we've got some people waiting, we're starting a little late. If you don't mind, I've got some excellent panel people with me, but I think we can run into the slideshow, and then after that, I can formally introduce everybody if that works with you, Jen.
That's perfect. Go. You should be able to share your screen any day now.
Yep. So thanks again for attending. Thank you, Jen, for the awesome introduction, and I'm gonna hop right into it. So, like I said, what we're gonna do, folks, is we're gonna do a slideshow presentation. We're gonna keep it fairly brief. Then we're going to do a very extended Q&A with some experts, and I'll do an introduction for them after the presentation. So without further ado, we're going to hop into it, waste no time, think about some awesome questions, and we'll be ready to interact after the presentation is done. Thanks very much, and let's rock and roll. There we go. Stand by. Excuse me, party.
You want me to sing you some hold music?
No, I don't know what's going on here.
It's getting hot here. It's trying to go with your theme of hot recycling.
Yeah, right. All right, we should be going here in a sec. All right, thank you for bearing with me there. So we're going to go through hot in place recycling. We're going to do what we're going to do is we're going to go from along like a reverse funnel. So we're going to go from the overarching hot in place recycling, and we're going to funnel down to the specifics, the environmental, the economical impact, the positives, and then we'll have the question and answer. So without further ado, this is hot in place recycling presented by me. And then, like Jen said, I work for Gallagher Asphalt. So who the heck is Gallagher Asphalt? So some of you may know, some of you may not. Gallagher's been in the industry for 95 years. We're active members in NAPA, ERA, NCAT. It's you name it. We're trying to be as active as we can, as many associations, IPA, WAPA, etc. We have 4 plants in the Chicagoland area. The main plant is based out of Thornton, Illinois. The other plants are Bourbonnais, Joliet, and Chicago. We do a little bit of quarry mining. We operate next to the second largest limestone quarry in North America. It's the Thornton Quarry. If you're ever in Chicagoland or you drive south and you go 294 or across 80 going into Indiana, you'd see it. It's absolutely massive. We work hand in hand with Chicago Testing Lab, and I'll get to that. We have some excellent experts of testing and laboratory experts with us today. And then Gallagher's mainstay business, as you can imagine, is asphalt paving. However, we do concrete, we do excavation, we do decorative asphalt installation called street print, and then we do hot in place recycling. So we have experts in the construction side that do what traditional paving is. Then we have experts in the recycling side, and we have experts doing concrete, and then we do the street print. So we're not just hot in place, we do many more things than that. Again, this is, I'm going to click through this fairly quickly, but these are some of the associations, some nice representation of where we're active industry members. Like I said, this grows as much as we can. We try and be as active in as many membership organizations as possible. So hot in place recycling, where have we been? Gallagher Asphalt's been all over the nation for this. As you can imagine, I'm sure if you've heard of Hot in Place, we're not the only people who've been all over the nation. So we've been anywhere from Michigan to Indiana to Illinois, which is the Midwest. We've been out to New Jersey. We've been to Tennessee. We've been to Georgia. We've been to Wisconsin, Minnesota, Missouri, Alabama, believe it or not, California. And next year we're going to Virginia. So Hot in Place recycling is not local just to the Midwest or Chicagoland like traditional paving is for asphalt plants. Hot in Place recycling is a nationwide process that can be used and benefited by many people. And that's why we're here today talking with NACE. So what the heck is Hot in Place recycling? Now you probably are like, geez, Joe, when are you going to get there? So Hot in Place recycling, this is the federal highway definition, is an on-site, in-place pavement rehabilitation method that consists of heating, scarifying, mixing, placing, and recompacting existing bituminous pavement. So very, very simply, that's what it is. And I'm sure you're wondering, what are these candidates? What the heck, what road would be great for Hot in Place recycling? And I'll kind of get to that in the next slide. So the next slide is a great slide that shows where Hot in Place recycling fits, right? So Hot in Place recycling is one of the many recycling processes that people are using nationwide. And we encourage and promote anyone who uses recycling or anyone who uses a process that benefits their roadway, right? So you can see on the left that cold planing, a mill and overlay, is a traditional process that can be used from a good road to a fair road to a poor. And we know this. Sometimes we do it when it's very poor. We might do mill and overlays a little too often sometimes. Hot in Place is that step that goes right when the road is getting to a point where there's top-down issues or the top surface layer 3 inches and above is having some cracking, thermal cracking, fatigue cracking, stuff like that. And Hot in Place is the first step of pavement rehabilitation. It's an affordable way to recycle your roadway that's already there, and then you can put a capping material on top of it that you can build structure with the road. You can save the road a myriad of different ways and be creative and effective in using Hot in Place recycling to ensure that your road is salvaged in a way that it can be brought back to a life where it used to be. And so rather than doing a mill and overlay where there's traditionally not structural benefit and there's traditionally not, you're traditionally paying quite a bit, you can use Hot in Place recycling for that 3 inch end to the top surface cracking. The next step is cold in place recycling. If you have cracks or you have issues, you have a structural issue, Hot in Place is Hot in Place is not the solution for you. If there's any base failures or structural issues, you might want to call on a cold in place recycler, or that next step would be a full depth reclamation. Not obviously, but we encourage recycling, like I noted, and I'm not an expert on cold in place, but I can tell you that if hot's not the solution, you can always look to cold, and if cold's not the solution, you always look to full depth. And sometimes you have to unfortunately do a reconstruct. There's other, as you all know, there's other operations that can be effective in helping fix a roadway. So that's kind of where Hot in Place fits in. So what the heck are candidates? Well, here's some typical candidates for Hot in Place recycling. Hot in Place recycling, kind of like I noted, I got a little ahead of myself there. Hot in Place recycling can be thermal cracking. Hot in Place recycling can be something that helps with raveling. It can be something that helps with fatigue cracking. It can be something where rutting where maybe you have the wrong mix design on a road and it's just rutting due to traffic going over it and the wrong mixes there. Hot in Place is that's a great candidate for Hot in Place to help you fix those ruts. Or patches. Now, let's say this happens often. Let's say you have a roadway that has, let's call it, utility cuts 7 times across a road over 4 miles. And you're like, geez, I want to get rid of those vertical edges. Hot in Place is a great way to make that road monolithic by going over it, heating the road up, mixing it, rejuvenating it, and making that mat monolithic and getting rid of those vertical edges on patches. So if there's an HMA patch in the roadway, that's a great candidate for Hot in Place, as long as it's not structural. So we kind of know what the candidates are. We've been talking a little bit about that. What the heck are the non-candidates? Well, non-candidates would be these. So delamination, if there's no bonding course whatsoever, Hot in Place is not going to be a great candidate to help you because there's no way to there's no effective way to bring that bond back together effectively for your roadway. We would not be doing a service to the respective township, county, or municipality that has a delaminated surface. Unsuitable base. We see this a lot in Chicagoland area. Alleys and roads used to be brick. We've put pavement on top of the brick. Well, if there's not a sufficient amount of asphalt, call it 2 to 2¼ inches for hot in place recycling, and there's an inch and it's on top of brick, it's not going to do anything. Well, excuse me, it's not going to benefit the alleyway or the roadway if there's something with unsuitable base underneath it. Overpatch roadway. Oftentimes we see candidates that have just been hit a little bit too often with cold patch. And so not HMA patching, but cold patch with the mixture that when heated up, the diesel does not appropriately dissipate in the chemical mixture of the cold patch does not work well with our heating process. It actually segregates the material more, and we cannot effectively help the customer nor the client nor the municipality if it's overpatched. And as you can see in the bottom right, a collapsing roadway. As I've noted, we're not the solution for structural integrity. We're not going to fix something that the structure and the base is failing. We wish we could, we would really love to help, but that's not something we can do. So I've talked the federal definition, what hot in place is. I've shown where kind of hot in place fits in, right? It's kind of before cold in place. It's before full depth. It kind of goes hand in hand at times with mill and overlay. We've talked about the candidates. We've talked about the non-candidates. Now we're going to go through the process step by step. So what's the first process? Well, the first step is actually it's not going out there. What we do, and we're going to actually get to this because we have some experts here on the panel from the lab, like I mentioned, so we'll actually open this up to Q&As. But before we go out there, we want to ensure success. So we're going to pull a set of either 6 6-inch cores or 10 4-inch cores on the respective roadway and do what's called a penetration test and make sure the road is actually a candidate, right? Because we all we can do is drive the road. I'll drive the road with you. Some of our other Gallagher representatives that work in the hot in place division can drive a road with you. We can go out, we can do a lot with our eyes, but we can't do everything. So we're going to pull cores, we're going to send it back to the lab, and we're going to make sure that we can actually help you out, because we don't want to put somebody in a bad position where we can't help you out. So before anything, that's what we're going to do. Now, let's say this road's a great candidate. We can make it happen. And we'll come back to this slide. So I don't want it. I know I'm moving a little bit here, and I apologize if I'm moving too quickly, but we can come back to this slide and I can go in a little bit more detail about the penetration test. And well, maybe not me, but the experts can go in more detail and show you what those numbers can look like for the feasibility of a hot in place roadway. There's a little bit of a show on this screen right here. But let's say this road's a great candidate. We're going to go to step 1. So what's step 1? Step 1 is the first preheater. It takes that pavement temperature to up to 180, 200 degrees. Very simple. It's just heating the roadway so that it can be used. It's malleable again. As we know, asphalt's a viscoelastic material. So if you're using that heat to heat it back up and it can be disrupted, our scarifiers, which you'll see in a few steps, can move that material around. So step 1 is that preheater. That's the first pass. It gets it hot, gets it warm again. Then it goes to preheater pass 2. So the second preheater with our process takes the pavement up to 280 to 300 degrees. So many of you asphalt people know, okay, that sounds about right. That's about the temperature it comes out and gets put laid on the road. Exactly. We're getting it back up to that temperature that it was when you first laid it down. We're actually targeting really 285 to 295. That's the sweet spot for us to make sure this pavement can be moved and disrupted appropriately. Behind that second heater is the rejuvenation step. And so the rejuvenation step is we have a rejuvenating agent that is applied evenly across the mat that is now very warm, and it's being soaked into that mat. And so the application rate ranges based on the roadway and the testing. It's typically close to 0.1 gallons per square yard. And we're spreading that around, letting it soak in. And then next step is we're scarifying. So we're moving and disrupting that mixture. And there's spring-loaded tines at the prescribed depth, which is that whatever the job calls for, moves this asphalt and lets the rejuvenating agent mix in more deeper at the appropriate depth, typically 1.5 to 2 inches. And as you can see here, and we'll get to this a little bit more too, because this is a great question often, is, well, Joe, what the heck are we gonna do with structures and manholes? Well, these tines or these scarifiers, they're bolts, they're spring loaded. So when they hit those structures, they actually pull up and they make sure that you're not going to disrupt the structure. So we scarify the material and then we mix it. So we have full width reversible augers. We uniformly blend this material, the rejuvenating agent, the warm asphalt, we blend it all together, and then it becomes a paving process. That's all it is. And so we pave. We reprofile the road, and we eliminate the center line joint. One of the greatest benefits of hot in place recycling is we have the ability, because we have the heaters and the oil on the roadway, we have the ability to change things on the roadway. And one of the big benefits is we overlap the joint. We make sure that the joint is sealed so water can't penetrate, because we have that ability in it. And it's a warm process. We use the thermodynamics and heat transfer to our benefit, and we make sure that the joint is eliminated. So we go over that, and this is actually a picture of chip seal right here. This is a chip seal roadway we did this year in Minnesota, and we eliminate that center line joint. The next step, again, very, very simple. It's a paving process. The next step, the next step is compaction. We're targeting the same densities as traditional asphalt. So we use a combination roller pictured here. It's a rubber tire and a steel drum, and we get that material kneaded and dense, and we make sure what we do is the old test where you do as many passes until you get to max compaction, then you take one pass off. And you make sure the density is where it needs to be, and you test it accordingly. So we compact the road. And then when we're finished with that, we have a little bit of a pause. We wait for somebody to cap our process. But before that, it's open to traffic. We have the benefit of our process being open directly to traffic right after the roller gets off the road. There's no cure time, there's no wait time. You can drive right on it. In fact, we like that because all these trucks, tires, they actually help make sure that the roadway is being rolled correct. You know, we roll correctly, but it's like thousands of little rollers on the road with these tires. And on the left, we've got a picture of chip seal. On the right, we've got a picture of surface course with an edge mill in a municipality in Illinois. And then we have some great pictures here. Excuse me. We have some great pictures here. On the left, again, is chip seal. And on the right is a road that looks really, really in tough shape, but the base is still strong. We did testing on this. We pulled cores, and this was an example of poor mix design. So this is a great visual image of, oh my gosh, hot in place can really benefit a road if it looks really abysmal. However, the base was strong. So that picture on the right is a great example of, geez, this road, if the base is still there, this road can be kind of not in the best shape, and hot in place can help us out. So that's a great example. Continue some awesome pictures. On the left is a great picture of some surface course earlier this year. On the middle is that roller eliminating that center line joint in a municipality with a curb. And on the right is a picture of us going down the roadway. Again, open to traffic. You can see in some of these pictures, the flaggers in the background. We're making sure everybody's safe. We've got a relatively short train, making sure that people can drive around right behind our process. Really not inhibiting traffic too much and letting the motoring public move the way they want to do efficiently and quickly. And then step 8 is capping it. So we recommend a myriad of different capping, but hot mix is the greatest, right? You want to put HMA on top of this process. This process can essentially be a leveling course in ways. And if you put HMA on top, you're setting yourself up for success. Chip seal is another great way to do it. Chip seal is extremely effective over the top of hot in place recycling. It's a great product on top of our product. Slurry and microsurface as well. There are different ways to cap this process and to drive on the roadway. And that's the beauty of this process. It's not limited to just HMA. It's not limited to just certain types of candidates. It can be chip seal, it can be binder, it can be surface, and then it can be capped with hot mix. It can be capped with chip seal. It can be capped with these different slurry and microsurfaces. So I've talked quite a bit, and we're getting to the panel. But what the heck? I mean, Joe, why the heck are we doing hot in place? You've kind of told us about it. Well, you're eliminating some really big. You're eliminating quite a few things. So you're eliminating the mill. You're eliminating a lot of trucks on the road, and actually the next slide kind of has a great visual for that. So a standard 2-inch mill and overlay, this is based on 20 tons. It's a comparison, an honest comparison is there's 215 trucks. If you were to do hot in place recycling with a 1-inch overlay, it's about 53 trucks on the road. So what the heck does that mean for me, Joe? Well, I know in my superintendent days, as you probably can imagine, I don't have as much experience as many other superintendents out there, but I did see plenty of times what we would do is we'd mill a road and we let traffic on it and trucks would hit it and it'd be open for too long. And then we keep on patching and we would just keep sinking money into these into this road being destroyed by our own process. We were milling, opening it up, reducing structure, and then roads are hitting it, and then we're patching more and more. Whereas hot in place, you don't have to do that. You don't have to take anything out. You can hot in place and build up, or you can mill half of what you were planning to mill and keep that structure so you don't have to patch over and over again. So that's a big benefit of the lack of trucks on the road, the lack of traffic being exposed to your milled roadway. So that's a great benefit of hot in place recycling. So, and I've just spoken about this, so we know what we've lost, right? We lost all the trucks. What the heck do we gain, Joe? Well, when you do hot in place versus a traditional mill and overlay, you're actually gaining structure. Whether it's chip seal, whether it's HMA, you are putting something on top of a rehabilitated surface that is stronger, tighter. We fixed a lot of the issues, the cracking, and we've allowed the structure to be built on top of that road. So you're gaining structure, you're building your road up for oftentimes the same, if not a little bit more affordable cost. And that's a great benefit of hot in place recycling. Typically it's actually quite a bit more affordable, but that's neither here nor there. And another big benefit too of hot in place, and I'll just say it while I'm on this slide, is hot in place, as many of you engineers know, heat doesn't stop at 2 inches. Our scarifiers stop at 2 inches, but heat keeps going. So when you mill and you take out 2 inches, like I said, those trucks hit the road. But when you do the hot in place, heat, and by the laws of entropy and thermodynamics, hot wants to go to cold. Energy wants to be balanced. So heat keeps going down and it tightens up those cracks that are beneath the 2 inches. I'm not saying it goes 12 inches deep, but it keeps tightening those cracks up to 4 inches deep and making those cracks a little bit tighter, a little bit harder to show through that top wearing surface. And then this is towards the end of the slide. It's a sustainable process. We did a study, a white paper in 2011, and we found that it has 28% less greenhouse gas emissions for heater scarification than the traditional paving process. That's exceptional, especially where the world is going, where we're trying to go as paving people, as we're trying to go as an industry. We want to be greener. We want to protect our earth and our environment. And this is a great benefit of that. Hot in place is more sustainable. And that's just something that we found in 2011, and we continue to find that's more sustainable than the traditional paving process. And then last but not least, certainly a little bit of recap. So hot in place is a proven process. It reuses existing roadways. It saves time, typically saves money. It reduces the road congestion like we mentioned. It reduces carbon footprint. And listen, I know some of you don't know Chicago very well, but we're still in the Midwest. It's performed by some pretty great guys. So you're getting a good crew and loyal people to help you out and make sure that your process is exactly how you want it to be, your road's how you want it to be. We won't stop until we help you out and make sure everything's right. And so that's hot in place recycling for Gallagher Asphalt in a very, very abbreviated slideshow. So I'm going to stop sharing. I'm going to turn it back to me. I see we got some questions already popping up. And I appreciate everyone bearing with me. And if we need to go back, we can absolutely look at some of these pictures and some of these charts if we need to talk through hot in place recycling. But John, if you don't mind, I'm going to introduce the panel. And thank you everyone for bearing with me. I see some questions popping up, so I appreciate that greatly. But I'm going to start with the panel and we'll get right into it. So on my left, on your right, I believe, I'm going to have oh, geez. I'm going to have Jeff Rothheimer, and we're going to try and figure this out here. But Jeff is the Director of Technical Services at Chicago Testing Lab. He's been with CTL since 2018. He received his bachelor's degree in civil engineering from the University of Illinois at Urbana-Champaign. He's a licensed PE in Illinois. Prior to CTL, Jeff worked from 2012 to 2018 as a consulting engineer on various roadway and building projects, and then he's responsible for managing, directing all geotechnical engineering, CMT laboratory testing, and specialty field testing at CTL. Among other tests, he's an instructor for IDOT Quality Management Training Program through Land Lake College, where he helps teach aggregate, HMA, PCC technician courses. So Jeff is, oh geez, I got a background going. I'm sorry, folks, but Jeff is going to be right here with us answering the panel. If we need to lose the background, we will. And then on my right, see if we can get Abdul in here. There we go. We've got Abdul, and Abdul is also a licensed PE. and he's registered in the state of Illinois. Abdul holds a civil engineering degree from University of Wisconsin-Madison. Go Badgers for those who are up in Wisconsin. Abdul Jones, sorry, I should have said go Fighting Illini, but they're having a tough year for us. Abdul joined CTL in 2015 as the Vice President of Engineering. At CTL, Abdul manages and directs all engineering aspects related to project development and project management. In addition, Abdul is responsible in part for the preparation, updating, and conducting training for various classes, including, but not limited to, quality, here it goes, quality management training program classes, and many other classes. Abdul oversees and directs all investigative and forensic testing activities for a variety of projects and pavement across sections. And Abdul has, as many of you know who are in Illinois, he's had a prestigious 3-decade career at IDOT prior to joining Chicago Testing Lab in the Chicago area. So thank you very much, Abdul, for joining us.
Thank you. Glad to be here, and also glad to be with you, John, and Jen, and everybody. Appreciate this opportunity.
We might have to lose the background here. And then last, but definitely not least, we are going to introduce John Danello. John is the Director of Operations and, Director of Hot in Place Recycling at Gallagher Asphalt. John has been in the road building industry for 30 years in various positions. He's done everything from estimating to building heavy highway jobs to managing asphalt and business development. And John has experience with a plethora of experience from plant production quality control, roadway quality control, laboratory quality control, and to actually being a chairman for the board of the Asphalt Recycling and Reclamation Association, which is shorthand ARA, and he focuses on the processes to reduce greenhouse gas emissions while using existing materials and saving customers money. John's based out of Connecticut, and his travel brings him across the nation, meeting new people like all of you every day. So we've got 3 awesome candidates here, and panelists here. And with that, we're going to get right into it. So,
Do you want to
Jen,
go
would
ahead
you-
and we'll start? Yeah, I'll start reading off the questions for the panel or whoever wants to answer them. The
Awesome,
first
thank
one
you.
comes from John. What is the maximum depth for the HIPR?
John Danell, would you like to take that?
Yeah, absolutely. Typically, the maximum depth is 2 inches. We'd like to focus in the 1.5 inch range, but if you have a 2-inch lift in there, then we would do 2 inches.
Same John. If the original mix design had an issue, then how does the HIPR remedy the issue since you're using the original material?
One second.
Got
I'm
that?
sorry.
Uh,
Want me to read it again?
No, Abdul, would you like to take that? And then John, if you wouldn't mind hopping in.
So again, I mean, sometimes the when we're talking about the mix design, so the the mix itself, we may have selected the right aggregate combination, and we have the right mix design and optimum AC content. But maybe the mix design, when we started the installation process, we did not really impart the right amount of compactive effort. And so in the slide, the one example that we highlighted was the rutting in the pavement in the wheel path. So again, it was it's very common sometimes not having the right amount of compactive effort and having the right imparted in place density. That is probably why we had the the rutting in the wheel path. So the hot in place process, we've reheated and we remixed, distributed the mix across the across that lane, and we now apply the proper compactive effort, and we restore the right cross section and the density in place.
All right, great. Sorry, John, did you want to add anything or move on to the next question?
No, I think we can move on to the next question, and we'll definitely handle that one well.
All right, so this is actually 3 in 1. Have you had a project where you had to make an adjustment to profile to remedy drainage, water on pavement issues? Want to take that one first, and then I'll go through the other 2 that are on this, or you want me to read them all at once?
No, like that. I like it one step at a time. John, would
Yeah.
you mind taking that, please?
Yeah, we've definitely had a lot of jobs where we've had to do a little bit of reprofiling. Now we can't move, a complete 2% road to a 1% road. But if you have a quarter crown of it in there, or if you need to move material from the bottom of the road up to the top, we can definitely work with profiling. And since we're using a traditional screed, we are able to level that road. So if you have a place that's catching water, we can bring material from behind that into it and level the road.
Great. How do you, there was just a comment with that that says, were there any issues with that process you did to remedy?
No, we do it on a daily basis.
Okay, great. How do you ensure that no deleterious materials like stone and subbase get into the mix during milling?
John, would you mind taking that one, please? And then we can comment as well.
Yeah, we actually don't do any milling, so we don't have to worry about that material coming back up. And when we do the pre-testing of the cores, we make sure there's thick enough roadway surface to make sure that we don't get into the base. And that typically is a 2-inch depth.
Yep. And I'll add a comment. Sorry, and then excuse me, sorry, Abdul. And I know I was going through very quickly, so I wanted to get the panel. I think that's more interactive and more beneficial for everybody. But the scarifiers disrupt. They do not change the mix design. They do not crush. We do not mill. We just disrupt, and we evenly distribute the rejuvenating agent, and then we mix it in. So should you have any questions about that, please reach out to us. I could send a video that has a little bit better example of what that may look like rather than just pictures, because sometimes it's a little tough to visualize, but it's just getting warm enough that the scarifiers and bolts can actually move like through that material in a fashion that allows it to be disrupted but not milled. And then, like John said, we're going to check the cores and make sure that the material is more than 2.5 inches, so we're not running into sub-base materials, because that would be a problem.
So again, we just mentioned the cores. In fact, we have the wealth of information that can be generated by the cores that we cut, and hopefully we're getting those number of cores kind of staggered across the pavement. So we're not always getting them in the wheel path. So we get them throughout the width of the pavement. So we are really getting a great insight into the thickness of the surface lift. Not only the thickness of it, but also the uniformity of that thickness throughout the project length. We also oftentimes we may not have a pavement fabric, so the cores will kind of give us an insight where that fabric is positioned in the pavement and how far is it from that surface. In addition to that, we have the ability of determining the extent of those top down, let's say cracking in the surface in that pavement, and how far it penetrates down. So in addition to these readily learned observations from those cores, we take those cores into the laboratory, and Jeff he could jump in now and kind of go further into the additional laboratory testing that we can do with those cores.
Definitely. Thanks, Abdul. So first thing we'll do, like we did all the stuff that visually looking at the cores that Abdul was talking about. Then now we're going to actually go into the meat of the core. So when we bring it back to the laboratory, depending on how deep the specification calls for, going for the HIR, then we will cut that top surface off. And then we're going to take that surface, and first we will do a bulk specific gravity on those cores, so that we can try to determine what the existing density was out in the field to make sure that was actually still good density out there, or if there was a density issue. And from there, we will actually melt down all those cores into one homogeneous group, and then split them off into 2 samples. One sample is going to be an as-is sample, where we won't add any rejuvenating to it. And then we will have a second group that we actually add that rejuvenation to. And then from there, once that rejuvenation gets added to the full mix, we'll go through an extraction and recovery process to recover that liquid of both the as-is and the rejuvenated liquid. And then that's when we go and perform that penetration test, what Joe was talking about a little bit earlier in the presentation. And all that penetration test is that there's a consistent weight sitting on top of a needle, and then we let it drop for about 5 seconds and let it stop. And then we see how far down the needle goes into the liquid material at room temperature. And that's your penetration number. So the penetration number, the lower the number, the less the needle has penetrated into the asphalt binder. The harder the material it is, more like the more oxidized that original existing binder was. And then the higher the number means that the liquid's softer, getting back to what the normal virgin asphalt binder was. So typically you would see on a lot of these applications that the existing binder that's been out there is in like the 10s to 15 range or so. And then when the Juvenile gets added back, that's when it will bounce back up to like in the 40s or so, which is pretty close to where a virgin binder would be at that room temperature.
Okay. This looks to be a quick on long runs of arterials, but how do you place asphalt around curbs, ADA ramps, and intersections? How hard is it to place HMA in those cases?
John, would you mind taking that one to start, and then we make another comment if it's missed. I'm sure it won't be.
Yeah, due to the fact that we're using a traditional screed, we have no issue going around those type of areas. Anything that a paver can get to, we can get to.
Right. I imagine the scarifying tines are strong enough to penetrate and move the material. Are there issues with structure frames moving? Should pay items be included for adjustments?
John, while you're already hot, if you don't mind hopping in.
Absolutely. The scarifying tines are designed specifically to go up and around all manholes and all structures, water valves, everything like that. There is no need to make those adjustments unless you want to raise them up because you're going to put a thicker lift on it. They are strong enough just to allow the heat to penetrate down through the second lift and remove the material. We do not like them to be solid, overly solid, or too rigid, because then the heat is not doing its job. We want to just heat that road enough to actually be able to drive those tines through and loosen the material correctly.
This process is not appropriate if the sub base is failing. Is that correct?
That is correct. I can handle that one.
Any issues with having several layers of chip and seal on top of HMA, crack seal material, or mixed design, including fibers?
John, you want to start with that?
Yeah, no problem. As far as the double chip seal, we have done double chip seals, but we probably want to cut some cores and bring them into our lab and run a heat test on them. Sometimes the oil, if it's got too much oil in it in the second lift, it can act as an insulator and actually reflect the heat. So we'd have to take that on a case-by-case basis, but we do and have done them. Crack filler does smoke a little bit, but it's actually an added benefit to our process because when it liquefies, it goes back down into the lower bottom end of those cracks and actually seals it. It keeps the water from coming out.
The next two are somewhat cost related, and I imagine that it depends on the situation. So let's go with this one. What are the costs compared to CIR and FDR? So I would say maybe how do the costs compare to CIR and FDR?
So I think I mentioned, sorry, I'm off on the side here, but oh geez, all right, we're traded. I think I mentioned, excuse me. I like making an entrance. I think I mentioned that we're definitely not, I'm not an expert on CIR nor FDR, typically because if we're using just the sense of hot in places, that first step in the process, and then it goes cold and then it goes FDR, it gets more expensive as it gets deeper, typically. But to Jen's point, there are circumstances that can change costs, but it's not always, but for majority of the time, it gets more expensive the deeper you go because there's more problems the deeper you go, similar to a traditional reconstruction. So if you're going to go 6 inches deep with anything, it's going to be more expensive than 2 inches deep. Typically how it goes. John, I'm not sure if you have comment on that.
No, I think you explained it well. I mean, basically, if you're looking at the processes, like you said, it's mill and fill, just milling, hot in place recycling, cold in place, FDR. Those prices go down as you go. What we can tell you though is we'll save you 30% typically over a traditional mill and fill.
Great. And then the last one is pretty specific cost-wise. And again, I'm sure it's probably going to be based on conditions, but what would the typical cost for 2-inch HIPR be for a mile of roadway, 15,000 square yard? I'm assuming square yards. Kind of based on conditions again, would you say?
Yeah, depends on yeah, it's a myriad of factors. It's not only that, but we have to be honest too with ourselves. You know, we travel around the nation. We're based out of Chicagoland. If it's only 15,000 square yards, it's going to be extremely expensive. If it's 500,000 square yards, it's going to be more affordable. But the budgetary number typically ranges anywhere from $5 to $6 a square yard to up to, if it's going to be very, very minimal, more than that. So it just depends on the mobilization, the condition of the roadway, all sorts of factors. But it's a range in that range, budgetary, you could call it $5 to $6 or more dollars per square yard. And then that equates to a very affordable ton price typically. And we can always talk more about that on the side or formally if there was an opportunity to do something like that. But it really depends. 15,000 square yards would be, pending the location, could be fairly costly because it's not a very large amount, respectfully. John, if you have any comments on that.
No, I mean, that's well said. And, we'd like to go into a specific location and do about 40 to 50,000 square yards. And of course, that keeps the mobilization costs in check. But what we also tell people, especially counties that are working together, is that we can do 3 or 4 counties at once. It doesn't have to be all those quantities in one street. So we can jump around a little bit. We're very mobile. And if we get a group of people together, a group of counties that want to work off each other's bids, piggyback off a bid, then we can make it more palatable for sure. But the $5.50 to $6 is a good budgetary number. That's correct.
Great idea, John. I love the collaboration among counties. How soon afterwards do you need to place a top coat?
So we can probably all speak to this, but it varies depending on the specification of the state. If typically you can leave it open for several days to a week, and it's an assurance that makes sure that the hot in place is doing its job and it's holding together, and then you can place it. And for example, in Minnesota, what we would do is we would do the chip seal. We'd reheat the chip seal and we leave it open for a week, and then they make sure everything's all sound, and then they chip seal after that. John has more experience than me in that regard, but in Illinois, I know the specification is actually 48 hours. So it kind of depends on your state specification, but also depends on the condition, not the condition. It depends on what process you're doing as well, and when your contractor can get there often. Sometimes things happen. Last year we had a strike in Illinois and we left poly leveling course for 7 weeks open, and we checked and tested and we paved on top of that. So it kind of depends on the situation. I'm sure John Abdul, I'm not sure if you've commented on that, Jeff.
Yeah, again, it just depends on the specification. Typically, you are seeing it covered up in 2 to 3 days. But if you run into an issue where you're having scheduling problems, 2 to 3 weeks is not uncommon either. Definitely before winter.
Especially in Chicago.
Yeah. Do I have an accent, John? Don't be like that.
Oh, no. I'm all a good friend. How many miles can you typically recycle per day?
John, you want to take that? You got the numbers going in your noggin.
From a production standpoint, you're probably figuring 8 to 10,000 square yards a day. So that's just under a mile.
All right, great.
If we're slowing on questions, I do have 2 that they're asked very often. So we'd probably like to ask the panel. Yeah.
And if anyone else has one, just pop it in the chat.
Yeah, please. So often we see it, and I've got a few that I just see a lot. So I wrote them down. I'm going to ask them to our panel here. But one of the questions we get a lot is, what's the typical service life of hot in place recycling? And I'll kind of, if you don't mind, I'll let each expert speak on that, because it's a more technical answer than just, it's going to be, 20 years. There's a little more to that. So Abdul, if you don't mind starting, then we can go John and Jeff and make sure we touch all the bases and commentary.
So again, we really discussed earlier what the appropriate time and when is hot in place is the the ideal processes for pavement reservation. So ideally, if you have a roadway that you're trying to get some pavement reservation done on it, but so as you hit it at the right time, obviously this might give you definitely 8 years, 9 years, 10 years out. Some roadways may not be as fortunate, because what you started with itself was not right at the service level. So you may see just probably 4 or 5 years on it. So the base and the surface that you start with will definitely impact and kind of decide how far the hot in place will take you on this process. Jeff,
Yeah, John or Jeff, you want to jump in, or Jeff?
Yeah, sure. I'll jump in real quick. Like, the thing is, too, I agree with everything what Abdul said, and being one of those things that maybe what showed up on the top surface was surface down cracking, but then maybe after a couple years after the HR comes through, maybe there's a base issue that happens that comes and perpetrates up that could affect the life too as well. So I mean, it's one of those things of what we know from what the cores and stuff like that, and kind of going through, and if it's a good candidate or not will determine that service life. But like Abdul said, I kind of agree with those years and stuff. So.
Yeah, and I concur as well. One thing that we kind of left out of this presentation a little bit that we probably should bring back in and talk about, though, is a lot of the time these roads that we're doing this work on was designed for 5, 6, 7,000 cars, and now they're getting 25, 30,000 cars a day. So when you're doing the traditional mill and fill, again, I know Joe touched base on this a little bit. You go 2 inches, you put 2 inches back, your net gain is 0. So when you can actually come in hot in place and then put an inch of asphalt back on it, you're growing that structural integrity. That's really important. Again, as far as the service life cycle, it also depends on what you're putting on top of it.
John, thanks for really bringing this one point. This is something that should have been, always mentioned and highlighted. I mean, one of the very, one of the most favorite things that I prefer and I like about hot in place is the because we're not milling, we're not removing anything, or even if we are milling, let's say we want to mill 1 inch instead of scarifying, removing 2 inches. The ability to impart, to add structural, numbers to improve the capacity of that pavement is tremendous. So the mere fact that we're adding structural numbers and we're increasing the capacity of this pavement is huge, because let's face it, traffic volumes, they always increase. Very rarely you have a roadway that was designed for X number of ADT and it went down. They always go up. So by not having to mill and adding 1 inch, 2 inches, when you improve such roadway, is tremendous.
Great. We have another question in the chat. Have you ever encountered any segregation issues with your mixing process? Are there challenges, issues when doing HIPR on a larger IL 19.0 stone rather than a surface mix?
That's an excellent question, and we get that a lot. I'm going to kick that to John first, then back to Abdul, please. So John, if you don't mind answering that, and then Abdul with the follow-up thoughts.
Because of our mixing operation, we don't see segregation due to the process. But when you'll look like you might appear to see segregation is if you have like a 19.0 for a small stretch and then 9.5, just because of the bigger air voids, it looks more opened up, but it will look the same as if you laid it back down with a paver. So we do not see segregation with our process. Some of the other processes with hot in place that possibly use a milling drum, you might see some segregation or some cracks still with that. That's why we prefer to use the tines instead.
And again, John, if I may add, here the insight that we can, obtain to the, from the cores, obviously, and it's always important to stagger those cores from the right side to the middle of the lane to the left side. So this way you're determining the exact thickness of that top left. And, having any variations, probably we want to, again, adapt and adjust the thickness of our, scarification process and how much, the hot in place is penetrating through. So if we know that our surface lift is going to vary, maybe that's where sometimes, because we have 1 inch surface instead of 2 or instead of 1.5, that we're reaching deeper into the binder lift, if you will. And, that's where sometimes the source of this, what seems to be segregation.
Do you have any comments, Jeff?
No, I think we're good.
Thank you. Thank you both. That was an awesome answer. Great question, too. Thank you for asking.
We have 2 more questions, and then we're coming up on the 3 o'clock mark. So let's get these 2 in real quick. How do you tell if the base or sub base is bad?
Abdul, if you don't mind, and Jeff, and then John, if you got any comments after that.
So again, we when you're cutting these cores, obviously we're trying to determine how uniform, the density and the top lift, and we're also looking at the lifts, subsequent lifts below. There are, obviously tests you can run. You can, on these lower lifts as well. It is very important to determine the not just from the in-place density, but you can also run, the tensile strength and determine if there is any low values as far as the tensile strength itself. So, the bonding, of the asphalt to the aggregate, if there's any stripping. So, you can visually sometimes determine how adequate the base, or you may have to go into further laboratory testing to see if the base is sound, or not.
Yeah, like I'll add on to Abdul, like the visual portion of it, like you can visually see in those cores that come into the laboratory if there's any bottom up cracking that's happening that could cause maybe be evidence of some base issues, as well as if any of that base is starting to deteriorate at all or anything like that, causing those base issues to happen actually in the pavement structure.
Okay, great. Sorry about my dog. What is the structural coefficient of the HIR as compared to the hot mix asphalt?
Awesome question, Abdul.
Yeah,
That's a really good question.
Yes. So again, if we're let's say we're just looking at the top 2 inches surface, if we're looking at the amount of rejuvenating agent that we're adding, and we've achieved the right improved level, we took those penetration numbers up and we restored its elasticity, and then we also achieved a proper in-place compaction, and the density was again restored into the, let's say, 93%, 94%, 95%. I'll tell you what, those values are going to be as comparable and compatible with the close to what a hot in place structural coefficient of a 0.4 to 0.45 for the surface left. Absolutely.
Jen, do we have time for one more question?
I was actually just going to do this one last question, and then if you have any others, you can contact Joe directly. With your slide saying the mix is heated 280 to 300 degrees by the second heater pass, is that the average temperature of the intended heated asphalt thickness? If so, how hot is the surface exposed to the flames, and have you run into issues burning the mix?
Great question. Very, very often asked. I'm going to hand it off to Abdul, Jeff, and John, and then we'll wrap up. And the next question too, just send that to me, like Jen said, and we'll answer that on the side. Thank you very much. So Abdul, please. Or John, would you like to start? You've been quiet for a second.
Yeah, I know, and I don't like being quiet, so thank you very much.
We know that. We know that.
I'm Italian. I'm always talking with my hands, right? The temperatures that we showed in those screens are actually surface temperature. And then we rely on the heat transfer to go down lower to keep it adequate to do the recycling process. So those temperatures showed were surface temperatures. And no, we do not burn the top lip of the asphalt because we use temperature guns and quality control to make sure that doesn't happen.
All right, great. Thank you.
Or Jeff, man.
Yeah, I was really going to,
we're actually. Oh, sorry about that. Go ahead. I was just going to say we actually Jen Irvine. We do have a recording. We will ask our friends with Hot and Asphalt if they would mind giving us the slides so we can also post those. But we do have the recording. It typically takes a little bit for that to come back from Zoom, but they will have it to us and we'll get it posted online. Thank you all, and thank you to everyone at Gallagher for participating, and for all of you online. Again, the PDH certificates will be sent out via email next week, and then mark your calendars for our next NACE Connect, which will be Thursday the 19th at 2 o'clock. Thank you all for your time, and we appreciate everything you guys do.
Thank you, Jen. Appreciate it. We left you on a cliffhanger, so please contact me for the end of that answer. Thank you, everyone.
thank you.